Yeah, I really like sending the memes to fellow machine learning engineers. The meme of just like a random crack in the wall, and it just says statistics. And then someone like a business person walks by and like puts a frame on it, and then they like write machine learning, and then like a whole bunch of people gather around like, oh, this is amazing, and you're like, I'm not sure what you did different. Like,
Welcome to the Forward Slash podcast, where we lean into the future of IT by inviting fellow thought leaders, innovators, and problem solvers to slash through its complexity. Today, we have with us Stephen Nord. Stephen Nord is a data scientist with a background in actuarial science. That's a tough word for me to say, actuarial. I always have to say it slow. And software engineering. He recently completed his master's in computer science, specializing in machine learning at Georgia Institute of Technology. Stephen is particularly fascinated by the parallels between how machines learn and how living things adapt and evolve. Outside of researching ML topics, he likes traveling and exploring nature with his wife and son. Welcome to the podcast.
thank you for having me.
In your bio, Stephen, you mentioned about you're fascinated by the parallels between how machines learn and how living things adapt and evolve. Tell me that's an interesting phraseology. Tell me a little bit about that.
Yeah, definitely. I really fell in love with machine learning because it really is an adaptation or a combination of stats and computer science. And really, machine learning isn't a new thing. It's been around forever. It's been around since about the 60s, and really we just have the computing power now to get it to work. And so really, there are three components of machine learning. They've kind of branched off to make smaller branches, but the three foundational ones are supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is really just labeling data, and I'll just draw a parallel to how my son is learning. Like I take him to the zoo, and I'm like, "Oh, look, a bear," and he starts like noticing it, and then I start pointing to the monkeys, and he notices that. So it's really just I'm going through and labeling all that information, and then you have unsupervised learning, which is just grouping data. So he starts noticing the lions and the cheetahs, and I'm like, those are all sort of in the same category. They're all big cats. We also have a cat at our house, so now he's assuming that why is that not in the zoo? And then there's reinforcement learning, which really is my passion. I think it's fascinating, and it's really optimizing something. And really, what he's currently optimizing is learning how to walk. And so what he's doing is he's taking input from the outside world, and when he falls, he's like, "Oh, I shouldn't do that." And if he makes it a couple steps, he's thinking, "Oh, this is a really good reward." And the way it really works is in computers is they don't get the emotional input of like, "Ooh, happy feelings," like, "Ooh, I'm hurt." But then it's like we feed it number systems. So a positive number says like, "Ooh, like I want you to continue doing that," or a negative number, and we really don't want you to do that. You really could reverse it if you wanted to take sort of an adverse reaction to it. For instance, like if you're going through a maze, I don't really want your time to be maximized. I really want it to be minimized. So you take a negative approach. And you say like, "Ooh, I'd really like you to go as short as possible." Right. So I just think with that, it's fascinating to see how these things are really not much different than the way humans kind of adapt to the world around them, or animals in general.
And do you think like reinforcement learning is kind of more akin to how we as human beings kind of interact with the world around us? Is it more similar than what, the other types?
I'm very curious to really look into like the psychology of how these really adapt to like the human learning, uh, because I think there is just some sort of memorization or pattern recognition, and I think that goes back to the supervised learning, going back to the animal classification, or you start even looking at like the housing market, you start seeing like, oh, this house is bigger. Like you generally have a sense of how much it costs, and then you just get different attributes.
Reinforcement learning. So the interesting thing about that, and you can probably correct me, but it's like you kind of have to come up with that reward up front. You have to kind of architect it that way. You have to foresee like this is the reward system that will lead to the best outcome. Is that right?
Yeah. So really, with reinforcement learning, you're taking a screenshot of what is currently happening. And so I did a project for like when I was first learning reinforcement learning, just to teach an agent to play the game Mancala. I said, here's a screenshot. There are marbles in these holes, and it's your turn or it's my turn. And from there, it tries to optimize like what is the action I can take at this state at this very moment. It has no recollection of the past. You can manipulate the state to say like include some of the past, like include the last three moves. But in this one, it was a rather simple version, and so you're able to take that state and say find the maximum action to increase my probability of winning the most. Another project that I did while at Georgia Tech was really my favorite one. Was I had to teach two agents to cook a soup, and they'd actually coordinate as well. So this was what made it even more interesting. When I did Mancala, it was just one agent, just go at it, do what you need to. But with coordination, you don't realize like the amount of effort humans really have to like think about like I can do an action to optimize my part of it, but like I need to consider like my teammate, for instance, like playing basketball. With the cooks, they had to take 3 onions and put them in a pot, turn on the oven, wait 20 seconds, pull it off, put it in a bowl, and then serve it. But in the game, the only reward is really you get 1 point for serving a soup. Now imagine you've been put into a room, told nothing. You just see some piles of onions, a pot, some plates, and a window that you can put stuff in. And you just start doing things. You start like grabbing an onion and putting it down, moving it to the other side of the room, turning on the oven, turning it off. You're not really getting any kind of feedback. It'd be really hard to learn. And so I ended up manipulating what they call reward shaping and saying, oh, you get a point. You get a point for picking up the onion. You get 3 points for turning on the stove. You get 5 points for waiting 20 seconds and pulling the soup off, and then you get 20 points for turning the soup on. And I was getting tons of rewards, but I wasn't really cooking any soups. And I'm like, what's happening? Well, what I've now taught these agents was to literally just pick up an onion and put it back down, pick it up, put it down, put it up, put it down. And it's fascinating because I'm like, you really are doing what I told you, like optimize your points and just pick up the onion. So then you had to get creative and say like, well, if you pick up an onion, don't just put it down until you lose that point that you got. And so really just learn that, oh, it doesn't help me to just pick it up and put it down. And that turned out to be a very effective strategy. And then the coordination pieces, there's sort of like a centralized or a decentralized. And with this one, it was simple enough that I could do a centralized. And what that really means is create an action for like both agents in a state. And so like instead of 6 actions, now I have 36 actions, because you're saying, what does the first agent need to do and what does the second agent need to do? Right. And then you train the model, and then you just kind of what they call a policy, which is just like a contract. So like when you're in state 37, take this action. And both of them have the same policy. So they both knew like my job is to do this when I see this state. And that was, again, really effective. Decentralized is where they both kind of learn independently, go off and do their own thing, and they're just kind of getting feedback from each other in the world. And really, that's how things are going to end up moving.
Speaking of vegetables, do you know what the difference is between a black-eyed pea and a garbanzo bean is?
I have no idea.
Black-eyed pea can sing us a song, but a garbanzo bean can only hum us one.
That's good. I like it. I love dad jokes. But really, in terms of a practical business standpoint, you see it a lot in large language models now, which is really kind of the trend right now. A lot of people are talking about NLPs and large language models, a lot of because of what OpenAI is able to do. They started with just large language models, and what large language models are doing is it's taking the supervised approach. It says, you give me a string of words, I will predict the next word. And it just keeps making a prediction. And that proved to sort of like gain the structure of large language models, or the model of language in general. But now they've taken it to other steps where there's an approach called reinforcement with human feedback, RLHF. And so what this is now doing is it's taking that original large language model, and then they attach what they call a reward function, which they sort of graded the different phrases or different responses that they get to prompts. And then they run it through reinforcement learning algorithms to say like, hey, let's optimize this response. And then that's where like OpenAI has made a huge breakthrough in kind of getting creative with the responses.
Yeah, it's interesting. So That was one thing, like when I was looking at RLHF, reinforcement learning with human feedback, it's like you get it's you get a bunch of human beings together to kind of give their feedback about something, and then you train a different model to kind of mimic that reward system that they inherently had, and then you use that to say you're doing a good job or you're not doing a good job to the other model as it's trying to learn. Like who's teaching who? It's kind of crazy.
Yeah, and again, I always like to draw back to the human parallel. I envision large language models was really kind of how you like learned in second grade. Like, this is the sentence structure. Like, this is what you need to do. And then it wasn't until like high school or even college where you started getting like really deep feedback and saying like, oh, that's a really good paper. And in your head, you're probably thinking that's 100 points or 100%. Or they said like, oh, that was terrible. Here's a 20%. And then you're like, okay, like I need to really change my creativity levels. And so really, at that point, we start getting the human feedback or the human rewards, which I think most people don't really think about. But my wife always jokes about like your whole life is thinking about numbers, and it's like the matrix, like numbers running up the wall. Like I'm like the balance level that it takes to walk, and especially with machine learning, I've just gone down a rabbit hole of thinking about everything in terms of numbers.
Yeah, you're an actuarial science guy. I can absolutely see where you would gravitate towards machine learning with that background, for sure. Um, so generative AI, it's interesting, like how this thing has kind of just exploded on our world, right? As you said, we've had AI, machine learning, and stuff around for quite some time. I think the very first, like the perceptron, is kind of the first known like thing that just all it did was like linear separable things.
Yep.
Um, that was like in the 40s or something. Like it's been around a while. Like these ideas have, and as you said, the compute just we went through a time where we were ahead of the compute that we had available.
Yeah, I
Um,
really like sending the memes to fellow machine learning engineers. The meme of just like a random crack in the wall, and it just says statistics. And then someone like a business person walks by and like puts a frame on it, and then they like write machine learning, and then like a whole bunch of people gather around like, oh, this is amazing, and you're like, I'm not sure what you did different. Like,
yeah, wait a minute, this is the same thing. Yeah, that's true. It's very true. But like it's fascinating, this phenomenon that like I don't know, machine learning and AI weren't like they were never something you would sit around the dinner table talking about AI, right? Back in the day, like, unless you went to a movie that involved artificial intelligence that day, you might be talking about it. But like for the most part, you weren't. It's interesting to me that like large language models in particular, like the fact that we're now able to deal with language and semantic and meaning of words, that's what caused the explosion. Like that's the thing that now everybody's on, it's kind of unlocked that creativity for everyone to be like, oh, we can actually use this artificial intelligence stuff. Yeah, you can. But I don't know, what do you think about that? Just that it's just fascinating to me that language was the key, that they finally broke into language area. I mean, we've been doing some things like NLP, but it was very clunky and that sort of stuff. But this LLM and all that, it really seems to be the thing that has just unlocked everything for machine learning folks.
I feel like the big starting point for machine learning was actually Meta, or formerly known as Facebook. Their facial recognition was, I think, interesting enough, was driven by the general public. We would
Mm-hmm.
all we'd all put images out there, and we would classify every single one of us. Like you would say, like, oh, that's Bob, that's Jim, that's Sarah, that's Katie, and over time, now we use it for security systems. The hardest thing about supervised learning, and I think that's why a lot of companies are trying to get away from it, is that it takes so much human involvement to label the data.
Mm-hmm.
And now I think Meta and Google are realizing that they're coming up with legal troubles of saying like, oh, we've been doing this behind everyone's back for so long, and now people are upset. And it's like, well, I don't know. Again, I don't put any cruelty in AI or technology in general. I think it usually just comes down to the intent that people have behind it. And so, what is Meta's intent with it? Are they really using it to try to become better and create higher security systems? I mean, it's really effective. Like, it can identify a lot of people without me having to like carry around an actual badge. And so, I think that's always the interesting aspect of what is the intent that companies have to use for it. And I think that's why even at Georgia Tech, I really emphasized getting an ethics course, just because machine learning in general, especially supervised learning, learns off of our past data. And I think all of us know our human past isn't the cleanest of slates.
Right.
And so how do we use the data that's out there, but make sure that we scrub it so that way machines aren't learning from our tainted past, I guess is what I would say.
Yeah, and I think, I mean, our brains are designed, maybe we're kind of like generalization engines, right? Once we notice a pattern, it kind of hardwires in a, this is my language, I don't know if that's the official, but it kind of hardwires a short circuit, right? To say, okay, I've seen that thing 7 times. Let me just put a little link here in my brain that says I don't have to go through all the thinking and rigmarole to figure that out. Let's just put a shortcut in there, and I just make that leap immediately. It's kind of the gist of how I understand it, being a generalization engine. But all of those links that we've put into our brain, those shortcuts can be based on flawed perception, and so when now we're trying to teach a computer to do what we're doing, it may be based on something that's flawed, which is really interesting.
Yeah, especially it's interesting to talk about like wiring in networks for us. I sometimes joke with my wife because I'm constantly thinking about AI, and I was like, you could really go to the zoo and just start mislabeling all the animals. And my son would go into preschool and be like, "Oh, that's a bear," and the kids are like, "That's a lion." And for a while, he would just be like convinced no. And it's not until you get a flood of new information, and it's the same with machine learning. It's not like if you fed it bad data, it'll learn that pattern, and you can correct it, or it can correct itself, or go off in its own little world, which is I think people's general concern with AI. And that's why building AI isn't always the thing. It's like monitoring AI. But it's the same with monitoring your child. Like you want to make sure that they're one learning what you were hoping that they learn from your lesson, and then two just using it in the right way. But going back to the mislabeling of data, I'm always curious. Like I'm always fascinated by it. Like you really could go through and relabel everything, even to the simple foundations of math. Like everyone says 2 + 2 is 4, and you would walk into a room and say like 2 + 2 is 4. But if everyone in the world started telling you 2 + 2 is 5, you eventually gonna start questioning yourself.
Yes.
It's like I don't know what to do now. Like I've had millions of data points that told me 2 + 2 is 4. Now all of a sudden people are changing the structure on me, and you'll eventually learn it. But it would take some hard wiring to get through that.
And I know what you all are thinking, the listeners are thinking. Steven said, I think about AI all the time, and you're thinking, wow, I'll bet this guy's a lot of fun at parties, right? Like, but I'm going to tell you, this. So Steven used to work with us at Liberty, and he is known as the absolute best dancer at every one of our parties. He's the one who would cut it up on the dance floor. So he actually is a lot of fun at parties.
And the funniest thing is everyone always would ask my wife, like, how drunk is he? And she's like, he's only had water. I promise you, he's only had water. Like, I don't know. It's just something in the water, I guess.
He's the dance guy. So he really is fun at parties. So just don't ask him about AI.
Yeah, I'll go down a rabbit hole.
You won't be dancing. You'll be busy talking about AI. Can you do both at the same time?
I don't know. We're about to try it at the next celebrity party.
All right. So we were talking earlier about reinforcement learning. And there's this notion of kind of reinforcement learning is different than like, a lot of AI is around predicting, right? And reinforcement learning is kind of, we're trying to move past that, right? Just being prediction engine, right? With reinforcement learning kind of is the key to that. Is that right?
I have been an advocate of getting away from the predictive models and moving more towards reinforcement learning. For instance, if you think about products, and if you really want a trusted product, you're saying like, oh, what is the longevity of this? Like, oh, I predict it's going to last 3 years. And then eventually a year down the line, it's like, well, I think you really only have like 6 months left. And at that point, companies think about like, oh, how to replace this 6-month product. But really what I would hope for is if I see the state of a product and I say, what can I do at this very moment to increase that product's longevity? And then in a year, get another reading, probably not wait a whole year, but get another state reading and say like, what does the product look like? And what can I do at this moment to increase it? And really with reinforcement learning, you can get different actions and it'll say like, oh, it'll increase it by 4 days, it'll increase it by 2 days, it'll take it down by 2 days. Or it's like, they might all be kind of zero at this point. And say like, yeah. And at that point, like, I've done everything I can to maximize this product's lifespan. And you're not necessarily predicting it, but you're actually encouraging it to improve over time.
So in a business case, I know a lot of people, when it comes to like doing predictions and things, one of the topics that comes up is like predictive maintenance, right? So you have a forklift and maybe you have some telemetry, metrics that you're recording from your forklift, and you notice that it's starting to shake while it's driving down the plant floor or whatever. So oh, I got to replace the wheels on it or something like that. But what you're saying is, instead of waiting until the bad things start happening and noticing those, you're talking about upstream from that, before that, and saying, how about we lubricate the wheels or whatever, and then that might prevent it from shaking at 6 months, and it would go on longer. Is that kind of the idea?
Yeah, the idea is really, with predictive, you're just kind of being passive. Like, you're like, well, there's nothing I can do at this point. I just know it has 3 years. Oh, by this point, there's nothing I can do. There's something like it has 2 years left, 1 year left. But really, your model could be telling you like it has 3 years, but you could increase it by like a couple of days if you do this. You'll destroy the product if you decide to put a nail in it. Like, there's some of the actions can be like bad, but some of them can be really positive. And I think at that point, you're trying to be more aggressive as opposed to just like passive and saying, oh, I got a prediction. There's nothing I can do, but I do know the number. And so I think it's kind of the idea of being passive versus being more aggressive with your model predictions, or not really predictions, but um, integrating AI into your product line or your software.
Another thing you mentioned in your bio, that you just recently got your master's in computer science. So your undergrad is not in computer science. Your undergrad was in actuarial science, correct?
It was statistics, and then it was a focus in actuarial science.
And how was your experience going for your master's degree at Georgia Tech?
It was really good. I really liked it. It really kind of went more into the theory of stuff. So being a stats, like being my bachelor in statistics, I had the foundational understanding of the math that went behind it. I think it may have given me an advantage. It kind of goes into like software development. Like, you can know the ones and zeros really, really well, and you may not need to know it for Python, but you really, if you know Python and you know the ones and zeros, and you really know how to optimize higher level languages or higher level programming languages, because you know the intricacies of the hardware. I think it's the same thing with machine learning. Knowing where it comes from, or really understanding how it's really learning, really helps, not only in making the models but also monitoring the models. Because, like I mentioned earlier, knowing it can deviate on its own. I know that's always a scary thing of people have with AI, is it can go off and learn its own thing. Well, sort of, but you can kind of guide that as well, and monitor it, and then sort of intervene before it goes off kilter or like too far off the trail. In my reinforcement learning talks, I always do talk about the ethics part of it, because of the scare that movies kind of portray AI to do. Uh, iRobot is actually a perfect example.
Hmm.
They, at the end, Will Smith talks about how he hates robots, and he goes into the scene of saying he was in a car accident, and there was an 11-year-old little girl who was trapped in the car. She has an 11% chance of survival. He has a 40% chance of survival. And he's saying like any human would know that you saved the little girl
Right.
over me.
Right.
Well, really, with reinforcement learning, what are they optimizing? They're optimizing the percentage of survival.
Mm-hmm.
What is Will Smith optimizing? He's optimizing life expectancy and percentage. So he's multiplied the 0.11 times her age and said like, oh, she has more value. This goes down a really dark rabbit hole of like, who knows what value is considered. I'm not saying that like younger is better than older, but like, this is where, if we were to sometimes take a step back, what are we looking to optimize as a human race? What do we value most? Um, do we value everything equally? And then you really are just taking percentages. And in that case, iRobot was correct, because they've taken the emotion out of it, and they've just said we're optimizing the likelihood of survival. I don't know what the right approach is, but I do think that's where big companies need to take a step back and say, like, what are we looking to achieve?
Yeah, and I think if the robot like could go back in time now and save the little girl instead of Will Smith, and knowing that Chris Rock wouldn't have got smacked in the face, you know what I mean?
That
I
is
think
also true.
that would be the right choice, right?
Chris Rock would definitely
He
be very thankful for
he
that.
would endorse this message. Yes. So you mentioned that you think that kind of understanding the kind of the nuts and bolts level thing is helpful. Do you think it's necessary, for instance, to like have like a statistics background and or not necessarily just a background, but a good understanding of statistics in order to do machine learning and to do what you do?
I definitely don't think so. There's definitely a ton of great engineers out there using AI that have been provided by libraries. And even with the libraries, like the large language models, you can introduce your own context. It's called RAG,
Mm-hmm.
retrieval augmented generation, where you kind of create your own specific database. And when a customer puts in a prompt, it goes to your database based off of the queries you write and say, like, when you see something related to this, grab these other materials, and it'll inject your own content. And then when the large language model sees all of that, it'll take the document with it and say, like, these are your company specific attributes that I need to consider along with the prompt. And that's, again, you don't really need to know the math behind all that. Is it helpful? Sure. And if you want to know the math, and you don't really want to go back and get a degree, Andrew Nin is awesome. It's Andrew, and then his last name is NG. He does a lot of stuff on Coursera. He's
Mm-hmm.
kind of the machine learning guru.
Oh yeah,
And not only
I love
that,
his stuff.
he's got an extreme gift for making complex topics just sound so simple. You're like, oh, is that all it is? And then people are like, oh, that's a lot of math. And you're like, yeah, but you don't really need to know the math. Um, I mean,
If you ever take one of his courses and he starts talking about the dater, you ever
yeah.
notice that he's the dater? He's fantastic. Yeah, I love that. I love that you brought him up, because the one thing that I kind of steal from him is like he always talks about, and he even puts it in his slides. Like, I'm going to teach you the math, and then I'm going to teach you the intuition. Right? He always talks about
Mhm.
the intuition of this thing. So it's kind of like the gist of what these algorithms are doing in an intuitive way. So as you're saying, I can forget about the math. As long as I have that kind of intuition level understanding of what this thing is doing, that's the more valuable thing, because it's you're not going to be able to keep all that math in your head. Like I don't remember. I got a math degree in college, but I don't remember all of those equations and stuff like that. But I do remember the intuition of what what's underneath an integral curve. How do you do that, right? I do remember that, but I don't remember all the equations. So I love his stuff. He's fantastic. Now it's time for our ship it or skip it.
Ship or skip, everybody we gotta tell us if you ship or skip.
What do you think about? Everybody talks about this being scared about like AI is going to replace human beings and humans and our jobs and all of that sort of thing. What do you think about that?
I've I've taken two approaches to this. I'm sure there's zillions of different paths, but my mind has gone down to either AI creates like robots and they maybe just do all of the tasks that we don't necessarily want to do. Maybe they do all of our tasks and we just live like cats and we just sleep on our couch and just wander around the streets and pick up whatever we feel like. Um, or I think if you were to talk to maybe some other people who are just inserting chips inside of pigs, is that AI and humans sort of merge. And what I mean by that is like, what is your brain sense like? If you've optimized all these models and you've optimized computer vision, you've optimized language, like if you install a chip in my head and I can all of a sudden speak 30 different languages, and they're like, oh, there's a new language today, let me just insert, like, plug in for an update, like, it essentially turns into the Matrix where you can learn something in 15 minutes. Like, I want to be a helicopter driver today. I'm gonna plug in. I'm gonna learn how to fly a helicopter, and then I'm just gonna go fly for a helicopter service today.
I know
Um,
kung fu.
I know kung fu. Yeah, I have no idea. I think it's always the two paths that I've gone down. I'm not really sure why. I think it's either we completely merge or we're completely independent of each other. But I really do think that, like, AI is already taking over a lot of, like, simple, I don't want to say simple, but like some of the like mundane tasks, and I only see that improving as we've seen Boston Dynamics create robots that can do like backflips. Like, what prevents them to creating robots that can work through factories? And it's like, well, again, like what are factory workers then intended to do? And people compare it to the industrial revolution, where we were all farmers, and then all of a sudden, like, tractor came along. We're like, well, what do we do now? And maybe you create superhumans where humans are just capable of working at such a high pace and a fast pace. Um, but again, what is the health benefit of that? Like, what happens when our brains are writing at 1,000% of what we were actually intended to be computing at? Maybe it's a great thing. Maybe it's not. But I'm not one of those people who have done the research on figuring out the neurons in our brains and how it can handle all of that movement.
So you're a ship it on the robots plugging us into the matrix and using us as batteries. Is that what you're saying?
I don't know. I mean, it would be pretty tight. I would love to just be able to fly a helicopter one day. Just be like, I feel like it. I feel like it. Why not?
My whole thing is I do think artificial intelligence, and I do think using machines is going to be beneficial to the human race, so to speak. But I would love to see, like, let's leverage the machines for what machines are good at, right? Don't try to make the machines become human. Like, let them do the machine things that they can do well, that they can do better than us, right? There are things that they just can do better than us. Let's do that, and let humans be more human. I think that would be the way to coexist, so to speak, with these artificially intelligent robots and stuff.
So I guess I have an interesting question. What would you deem as like the human product of? Is that like the creativity?
So what is the human thing that what do we still have? Well, I would say that kind of leads into the next question. So the other ship it or skip it. Like, what do you think about machines creating art and things like music and movies and all of that?
I mean, I guess to tie it back to your, I think it's very interesting if robots are taking sort of quote unquote the hard jobs, and humans are left to the creative pieces. And you mentioned something about superhumans. Like, think about superhumans with entertainment. Let's go with that. Like, let's run with that. If you think about some of the really good music out there, or even the music that's never been created because people don't have music creativity, and they say, like, I had this idea for this like really great song, this really great movie, and then they just work with AI, and then the two of them team up and just create like an epic movie that no one's ever thought of. Like, it really puts a lot of people in the game of just being entertainers. And if we're not, as humans, having to do really hard or mundane work, and really we're kind of looking for optimizing our entertainment, we would all serve a purpose and say, like, I had this idea for being creative. I think people would find it fun, and here's my idea. And AI takes it and multiplies it by 10 or 100, and all of a sudden we've come up with this new awesome movie. I'm not sure it'd still beat out Billy Madison, but it'd certainly be up in that category.
I think that the machine learning and AI and those sort of things can help us with creativity. I do find as I'm writing and those sort of things, I do use AI to help me explore ideas and come up with different takes on things. It would be great if AI could finally help the movie industry come up with novel ideas, and they don't have to remake every movie every time. And so, that would be great to have a novel idea every now and then. But there's no way you're going to tell me ever that a machine being optimized with statistics and all of those things is ever going to come up with "never gonna give you up." You know what I mean? Like, that's not going to happen. The 80s music, there's no way they would create that. It's just that you're not going to be able to convince me that an optimized, like, mathematically correct thing would generate 80s music. It's the human thing. That's got to be a human thing right there. That's what we still have.
Competition is on. AI versus 80s music.
Now we move on to the lightning round.
It's time for the lightning round. Rapid fire, don't slow down. Answer quick and make it count. In this game, there's no way out. It's time for the lightning round.
I'm going to ask you handful of questions. And these are very important questions. They're very important. There are right answers. There are wrong answers. And you will be graded. You'll be getting a score, and we will keep track of that. We will have a leaderboard and whatnot. So try to do your best. Question number 1, do you snore?
Not typically, unless I fall asleep in the car.
How often is it healthy to cry?
As much as your body tells you, I don't think you should hold it back.
If everyone in the world had to get married when they reached a certain age, what would that age be?
100.
Have you ever seen a kangaroo in person?
Yes, I have at the zoo. And even before, my wife and I traveled to Australia, and they're just all over the place.
And the final lightning round question, is it grammatically proper to capitalize the names of seasons?
Yes.
Yes. We would have also accepted no. All right. Well, I would like to thank our guest, Stephen Nord.
Thanks so much for having me.
If you'd like to get in touch with us or be a guest on the show, drop us a line at @caliberty.com. The / podcast is created by Caliberty. Our director is Dylan Courts, producer Ryan Wilson, with editing by John Corey and Jeremy Brown. Marketing support comes from Taylor Blessing. I'm your host, James Carman, and thank you for listening.